So I can just read this out because it explains it pretty well. So a Bloom filter is a data structure designed to tell you really fast whether an element is present in a set. So what we do is we compute this filter, which is basically a binary array, and then over that we can iterate really, really fast and understand whether an ID exists in that set, yes or no. So if we jump over to the next slide, we can sort of have a look at how that works. So you get an ID, a session ID, and you have a hash function mapping it out into indices within this array. And the size of this array is fixed. So there's a little bit of tuning involved in order to get it to the right size, but we can leave the low-level stuff out of this for now. But as soon as we create this array, we use it as a filter in Druid. So this is actually functionality that's built in. That's what it looks like. So we'll use an aggregation query to create it, and then use it within the filter. And this is basically what gives us the super interactive response times. And we benchmarked this, and so it looks like that. What you have on the x-axis is number of IDs. So you can see that for huge data sets, it's not practical to use an inner query. And that's where we use the Bloom filters. And yeah, that's how we do the complex filters on our application. Yeah.
Very good explanation too.
I hope so. Yeah, you know, it's one of those things. You have, as soon as you get your hands dirty with it.
Powerful.
Yeah.
It's a very powerful functionality. So it sounds like generally the benefits you're getting are not just the sub-second query response on sort of what we might call the single table OLAP queries, but also this ability to, determine this kind of cross data set.
Yeah, and the sort of security that we know we can scale. We know we can make this work for huge data sets. Yeah, and I think not a lot of people know about this feature, and it's
from what I've read about it. Well, it's fairly new even to Druid, but it's been in Druid for a couple of years now.
Yeah, I think we're one of the earliest adopters of this technology. As soon as we were testing it with you guys during implementation, and as soon as it was out, we adopted it.
Yeah, it's also. People really trying to understand it. It's highly mathematical. It's sort of higher order math, and so
So the little caveat, not little, but one thing that you do need to be made aware of, and I didn't really touch on that it is you have false positives.
It's an approximation.
Right? Yeah, it's an approximation, right? But for us, it made sense on huge data sets. And we tested this with long running jobs. It gets to about 0.5%. So it really is okay when you're dealing with millions and millions of IDs.
Yeah, you're making a trade-off of essentially a fairly bounded probability of a false positive, because you can tune it right to bound it to 2
I like to compare it to the hyperlog implementation in product-wise, that is. So we obviously use that as well, and it makes sense for us to use approximations there in order to have the interactivity for our customers. So it also makes sense in this case.
Yeah. Great.